Hello, everyone. My name is Ian McLaughlin, and I have a PhD in neuroscience. And today I want to talk about an interesting story that's been progressing over the past few years. It's a totally new approach to treating a variety of brain-related maladies, from Alzheimer's and Parkinson's diseases to traumatic brain injuries. And so when I say a new approach, I don't mean like a new form of medicine. This would be a largely normal medication. It's a molecule called ISRIB, and I don't know if that's how you pronounce it. Maybe it's ISRIB. I'm not sure. But what I mean by a new approach is that if it works, it would work in a way that no medication designed to target any of these conditions works, right? What it does is that it targets a system in essentially all of our body's cells called the integrated stress response, or ISR. And so when we use that term stress in cellular biology, we're not really talking about it in the same way that you or I experience stress. There are some similarities, of course. Basically just like, various events and changes around you in the world can produce, negative or challenging outcomes for you, right? Experiences that can potentially result in you suffering. Changes in and around your body can influence the cells in your body in negative ways. So stress. And in fact, you experiencing stress, prolonged stress in particular, right, can result in cellular stress. And so sometimes stress is beneficial, which, makes intuitive sense, right? Without a little stress and challenge in life, it would be difficult for us to develop proficiency or expertise or mastery. And it would definitely be difficult to develop resiliency to future stressors, right? And so the same kind of thing is true at a cellular level. So developing strength and building muscle, for example, is a pretty direct example of this, right? As your muscles are exposed to greater and greater demands, which can be in the form of progressively increased weight, or it can be, exposing your muscles to sustained demands, right? Like in the form of marathons or long distance swimming or rock climbing, things like that, right? All those physical demands literally results in micro tears in the muscle, little bits of controlled damage, stressing the muscle fibers, right? Hey, Scott, thanks for hopping in here too. Hey, David, thank you very much for the award. I appreciate it, man. Right, so you have these controlled little bits of damage to muscle fibers, micro tears, and so that's stress, right? And so that stress then activates various protein expression pathways in cells. So genes that wouldn't have been active or as active become more activated, right? Repairing those micro tears and then some. Which then puts you in a position where, the next time you're exposed to those weights or that strenuous long-term exertion, the muscle is better prepared. And so the activity becomes easier, right? So without that stress, that initial stress, the muscle wouldn't have any reason to build that strength. Those genes wouldn't be activated. Those muscles wouldn't have any reason to prepare for a future stressor. That whole system makes a lot of biological sense, right? Everything that our bodies do costs energy and it costs time, right? And so building muscle requires us to eat, expending, those caloric resources. And just like you wouldn't build a house that is capable of withstanding a raid by, Genghis or Genghis Khan, right? Since he's not around anymore, as far as I'm aware, you wouldn't build a house capable of withstanding a raid from the Huns or the Mongols for no reason, right? It's just biologically silly to prepare for events that are very unlikely to ever happen. And so our immune systems, our immune system is kind of similar, right? The immune system responds to a pathogenic threat, right? An infection, by generating cells that can recognize that pathogen again in the future, right? Because if it showed up one time, it's at least somewhat likely to show up again in the future. Okay, so the system that this group, and the group is called Calico Labs, it's a company. The group, which by the way, I love that name for the company, and they have a really beautiful website, in my humble opinion. So this company, Calico Labs, based out of San Francisco, is focusing on this pathway, right? This integrated stress response pathway. And so it's a pretty straightforward name for something in biology. Seldom does that happen, but it's referring to, despite the simple name, it is a pretty complicated network of processes and responses in cells. And so, okay, I don't want anybody to look at this next picture and try to extract a whole ton of meaning from it. But let's see if we can break this down a little bit, right? Let's just try and simplify it. So this is one of the, right, when you look at like a schematic like this is just like one of those interminable pathway schematics that biochemists just love, that would make even the most hardcore conspiracy theorists blush, right? A lot of arrows, a lot of squiggles, a lot of shapes with different colors, right? And so, by the way, this one is actually relatively simple. Check this one out here. Okay, so look at that. This is just for metabolism, right? All of this chaos is just for metabolism. Can you imagine having to put one of these together, right? Total nightmare. What? Yeah, exactly, Hugh. It's just like, what is that? To whom is this useful? Nightmare, total nightmare. Anyways, all right, let's get back to our integrated stress response pathway. On the left-hand side, or I'm unsure whether or not that's actually the left-hand side for you. But anyway, so back to on the left-hand side of this picture, you can see several green box arrow thingies pointing to each other, a series of events, right, that causes subsequent events in the cell to occur. And so let's say there's some kind of stressor, and there's some examples of stress, cellular stressors along the top of the image, right? Things like being infected by a virus, stressful for cells. Not having enough food, right? Amino acid deprivation, in other words, having your blood sort of messed up, just things that are threatening to the proper functioning of a cell, right? Those are stressors. So let's say one of those or several of those stressors occur. That's a stress signal, cellular stress signal. And so Scott says, my somewhat brief foray into weightlifting didn't build much muscle, but gave me varicose veins, plantar fasciitis, and a torn rotator cuff. Well, at least he got something out of it. I figure the whole learning and getting stronger, David says this, the whole learning and getting stronger, think apple to livers. So time for another glass of wine. Oh, I gotcha. Okay. Yeah, you got to challenge that liver, right? Got to keep it on its toes for sure. Yeah, Scott, like your experience with weightlifting, I think is probably pretty common because it's like, I think a lot of people just sort of, I'm not saying that you necessarily did this, but like a lot of people just perceive it as like just something that meatheads do. And like, if they can do it, I got to be able to do it because I'm not a meathead. But it's actually pretty complicated. Like you can very easily hurt yourself, particularly if you're doing like, the sort of old school, like deadlifts and, that kind of stuff. Like you can pretty easily really severely hurt yourself. And if you've never seen somebody on a bench press, doing a bench press, like a standard one with too much weight, it's horrifying, super dangerous. Anyways, okay, back to the cellular, integrated stress response. Okay, so we have a stressor occur of some sort. Okay, that's the stress signal. And then various enzymes, and enzymes are really just proteins that like do stuff in the cell, right? They make chemical reactions occur that wouldn't be able to occur without the enzymes making them happen, right? That's what enzymes are. And so these enzymes kick into action and then start a whole series of subsequent events that ultimately changes gene expression. It can increase the expression of a gene or it can decrease the expression of a gene. Applies, not apples. Damn autocorrect. Yeah, I have a very love-hate relationship with autocorrect, particularly when I'm trying to curse. Like it's so frustrating. And I use the swipe thing, and so I'm like, I don't know if you could tell what letter I'm trying to, or what word I'm trying to use by that hand gesture, but yeah, just stop censoring me, bro. I need to curse. All right. So the whole like goal here, that's the end result of this pathway, right? Changing the ways that genes are expressed in response to being exposed to a stressor. Okay, just like muscles growing stronger because genes are being activated in response to being exposed to exertion, right? The integrated stress response is changing gene expression in response to being exposed to stress. And so, they have enzymes that detect, right? They're like sensors. Being exposed to stress, right? They're sensors of stress. And then you have the things that those sensors activate. Okay, let's keep it up. Okay, so it's the things that these sensors activate that make this whole pathway a stress response. Okay, all of those sensors activate another protein that then will initiate changes in gene expression. And the end result is two main things. Okay, the cell stops generating as many proteins as it had been before the stress response. That's number one. And then number two, a set of, another set of special proteins, other proteins within the cell snap into action. They're sort of like the SWAT team or maybe like firefighters, right? They snap into action and cause a similarly special set of genes to be expressed. Okay. And so, when those genes are expressed, a whole bunch of things that work to protect the cell from whatever kind of stress it is becomes activated. And then, directly either repair the cell or stop the damage from occurring, right? put out the fire. And so it's pretty amazing when you think about it, right? When you think about a system like this, that not only did our like very complex and very versatile bodies and nervous systems evolve in the first place, amazing in the first place on its own, but there are even systems that are exclusively devoted to protecting and repairing the body that evolved along with it, right? And it's more than just the immune system. We have multiple systems like this. Pretty amazing. Okay, so by the way, if you listen to Joe Rogan's podcast, or maybe Rhonda Patrick, whom he has on fairly regularly, or maybe you're just interested in like longevity and lifespan and improving your health and cognition in general, something that regularly comes up are similar types of pathways to the integrated stress response, but different pathways in the body. So specifically heat shock proteins. So they're a different system, to be clear, right? They respond to heat, obviously, but that whole system, that whole system does sort of similar things to the integrated stress response. When we're exposed to overly high temperatures, obviously, like in a steam room or a sauna or something like that, various proteins are activated that are otherwise pretty much just quiet. They're not doing much. And those proteins work to repair any of a whole variety of damage that can occur in the cells following exposure to high temperatures. And that, not only, and, that whole heat shock pathway is also associated with longevity. Pretty cool. But anyways, story for another day. And that's why that's at least part of the reason why there appear to be some health benefits in terms of longevity to using saunas and stuff like that. Okay. Anyways, back to the integrated stress response right here. So there's a great article in MIT Tech Review, which is MIT Tech Review is a magazine that the Massachusetts Institute of Technology, one of the most famous science and engineering and math institutions in the world. It's a magazine that they put out, and there's a great art, and it's a great magazine, by the way. I highly recommend it. It's totally coherent and understandable. It's not like only for MIT people. Otherwise, I most certainly couldn't understand it. But so there's a great article that covers this recent work at Calico Labs that targets this pathway. And I'm happy to share a link to the article if anybody's interested. But so this MIT Tech Review article highlights the fact that one scientist in particular, and here she is, Carmela Sadrowski, they hone in on her work, right? They focus on her work. And so Dr. Sadrowski, whilst she was working in an academic lab at UC San Francisco, she honed in on this one particular molecule, right, ISRIB, and she did so more than 10 years ago. So to be clear, this is a drug candidate that originated in an academic lab, but now a company, Calico Labs, has been more thoroughly pursuing it since about 2015. And so, I think it's worth acknowledging that Dr. Sadrowski has a really compelling personal story that I think is just worth reading for people both inside and outside of science. Just a fair amount of personal tragedy and challenges. And I don't know, I certainly found it encouraging. But anyways, and inspiring. I have to imagine that, since this MIT Tech Review article just came out, they're probably getting ready to move forward and more directly attract some investment, right? The company has announced some human safety trials for other drugs that target the same pathway in similar ways in February, right? Which is, interesting for a few reasons. And that's pretty recent. So Scott says, yes, I learned that I do not possess the proper genes for successful physical improvement. While my phone kept putting asterisks in the words. Weird. I found that setting a D promptly turned it off. Huh, weird. But with craft beer. What are you drinking? And then, oh, yes, interested. Okay, here, let me just get it right now. Let's see. Boom. Here you are, my friend. Okay, I really wish Calico Labs would staff 100% by female tricolored cats. Yeah, if I was gonna have a cat, well, I guess, I don't know. Not really a cat person, because I'm allergic to them. But yeah, so I have to imagine that like they're putting out this article now for some specific reasons, not just like they're super excited about it. That's not how companies operate. Interesting for a few reasons. So first, this suggests to me that this company has invested quite a bit on this approach to confronting diseases via intervening, through this pathway, right? This integrated stress response pathway. The molecule on which they're focusing today isn't their only coal in the fire. They've invested in other drugs that are doing similar types of things, right? And so why would this team focus so much on this pathway? So here's a quote from the MIT Tech Review article. And so it goes, quote, crippling cognitive problems seen in victims of traumatic brain injuries, people with Alzheimer's, and even those born with genetic problems implicated in Down syndrome are not caused directly by the diseases or genes or trauma, but by the way cells respond to the resulting stress. End quote. Right? Pretty cool. And it's true. And, so in other words, it's not the specific malfunctioning protein that's causing something like Alzheimer's disease, right? It's not the amyloid beta itself or the neurofibrillary tangles themselves, right? That's most directly causing the whole set of symptoms, right, that we recognize as Alzheimer's disease. Rather, it's the cellular reactions that amyloid beta causes that ultimately results in all the dysfunction that we recognize as Alzheimer's disease, right? And this is actually a concept that's not all that dissimilar from the whole concept of the cytokine storm, right? That became fairly prominent about a year and a half ago, right? Where a person's own immune system is actually the primary source of the damage to the body rather than the pathogen, right? That's causing the immune reaction. Oh yeah, there you go. Hey, Asha, how you doing? How are we doing? We're doing pretty good. Can't complain. It's a very beautiful day here in Philly. The girls had a picnic. It's very nice. And my daughter has started a sort of a very interesting sort of Montessori style pre-K. Yeah, it's pretty cool. It's kind of sad that I'm not like around her as much anymore, but it's kind of unusual to spend, basically 24 hours a day every day with your child. But yeah, now that we're sort of starting to emerge. Anyways, how are you doing? Okay, so it's when it comes to like the things that we associate, the symptoms that we associate with Alzheimer's disease, they're not necessarily induced directly, proximally by the amyloid beta and neurofibrillary tangles, which are the sort of two classic hallmark signatures of Alzheimer's disease. Rather, it's how the cells react, right, to the presence of those plaques and tangles, right, that is the direct cause of the symptoms of Alzheimer's disease. So that that's a sort of concept. And so it's sort of like if someone would be if you're in a store and you own a store, let's say, and someone were to be in the process of shoplifting, right? And then the cashier calls the police, and the police end up calling in a military force, which then ends up shelling the whole store in an attempt to take out the shoplifter, right? And so in other words, the response is just dramatically disproportionate. The response causes far more damage to the store than the original shoplifter ever could, And so, Jonathan Rogers says, can Hashimoto's cause cytokine storms? Can Hashimoto's? I wouldn't think that Hashimoto's would. I would think maybe Graves' disease. So what Jonathan is bringing up is basically there are different. It revolves around thyroid dysfunction, and so the thyroid gland produces thyroid hormone, conveniently, and thyroid hormone is like one of those hormones that is like a master regulator. It influences so many things. It influences everything from like metabolism to cognition to energy levels to your immune system, like a ton of different things. And it's actually somewhat common to have either like hyperthyroid or hypothyroid. And basically it's like two sides of the same coin, right? Where if you have hyperthyroid, you generally speaking, you can sort of recognize when somebody's hyperthyroid. They're like very, very intense. Usually they're sort of susceptible to stress, very high energy. Oftentimes their body temperature runs really hot, or let's say they're easy to sweat, let's say. And their metabolism is just like through the roof. They're oftentimes very sort of slim, right? And yeah, they can have trouble falling asleep. And there are like way more problems that can result from it. Hypothyroid is like the opposite of all of those things, right? Generally speaking, people feel they put on weight very easily. They just feel like they're like slogging through concrete. They just feel sort of cognitively foggy, and they just don't have enough energy for anything. And either way, it is just like one of those things that like dramatically influences quality of life. And it can be kind of difficult to like find the right dose. So the treatment is to supplement with thyroid, and there's different kinds of thyroid, and different people respond differently to different kinds of thyroid. Like there's like armor thyroid, there's synthroid, in other words, there's like natural thyroid that's like derived from animals versus like a synthetic form. And for whatever reason, maybe it's known now. At the time when I was like learning, looking into hyper and hypothyroid, some people just respond very poorly to synthroid. which is why they have, I believe it's called armor thyroid, which is like the sort of natural thyroid. It can be difficult to find the optimal dose because different, people are different. And so, there can be, once somebody's diagnosed, there can be this sort of like period where, their dose is too high or their dose is insufficient. I know at least 2 people who have like really struggled with that. One of whom was while we were in college, and it was like really, really rough for her until she found the right dose. But yeah, great analogy. Yeah. The C3 pathway. Are you talking about the complement pathway or something else? So Frank says, hi, Ian. Great explanation. Instantly thought inflammation from exercise. Yeah. Many educated people repeat misinformation about ridding the body of inflammation. Right. Yes. And the same with body pH. Oh, yeah. Seriously. That one, body pH, like that's one of the dumber, like BS, new supplement company world ideas, because like it's extremely difficult and dangerous to try and like actually like seriously manipulate your body's pH, right? Your let's say circulatory system, your natural blood pH about 7.4. That's very tightly regulated, and if you deviate quite a bit, then there's going to be broad dysfunction, right? Because like, what is pH? It's just how many hydrogen atoms there are, right? And so ions specifically. And so like, if you're talking about proteins, right? Like the proteins that we're talking about in the integrated stress response, those are composed of molecules that have charged domains and different charges, and that's how they like interact with each other, sort of like magnets, right? And if you're like decorating the surface of a protein with a bunch of hydrogen ions, that can totally disrupt that protein's ability to function. And so if you're like dropping the pH significantly, that could be a very dangerous state of affairs. Or I think generally speaking, when people are like trying to manipulate body pH, through like alkalized water or whatever, they're trying to raise the pH. But like, what happens when you drink some just slightly alkalized basic water, right? You can do that. You can do that very easily. You probably could do it right now if you have like any ingredients in your kitchen. You could just mix a little bit of baking soda into some water and drink that. But what's going to happen? You're just going to be gassy, right? Because you have HCl in your stomach, right? That you will, come to a happy medium there. And what you're going to get is just some water and some gas. So you're just going to either burp it out or something else. Hey, from Ganas Vieiras. Oh, hey, Claudio. Gosh. Yeah, I would have to. Ganas Vieiras. Yeah, that like sort of little acrobatic part at the end of that word. I've lost that ability. It's a shame. And so that's great to hear. Asha says it'll be okay. Yeah, I know. Yeah. I'm doing great. Glad to hear it. You did it very well. Oh, you're being very generous, Claudio. And so Scott says, hypothyroidism, you just described my life. Maybe I should ask my doctor specifically about that. You could ask my daughter if you'd like. I don't think she would have very many insights. Yeah, totally, man. Yeah, I mean, generally speaking, if you're going to like whatever primary care physician or general practitioner or whatever, and you're complaining about some symptom and it's sort of mysterious as to what it is, generally speaking, they'll order blood work. It's very easy to test for your thyroid levels. And if they're out of whack, yeah, man, I mean, it can be life-changing. Like if that's a problem that you're facing and you just didn't know it, you've just sort of been struggling with it. Yeah, definitely. And it's not super expensive. I mean, assuming that you have health insurance, which I should not assume because it's not necessarily always easy to get health insurance. But yeah, I mean, it's not cheap, but it's not crazy, and like any doctor can do. You don't have to go to like a special place, like a research institution or anything like that. You can just easily order. Okay, anyway, so back to the integrated stress response, back to living forever, back to being able to treat conditions as broad as Alzheimer's disease, Parkinson's disease, and traumatic brain injury, perhaps even Down syndrome, at least according to this group. So back to that. So and also back to the store example, right? Where somebody's shoplifting, somebody calls the cops come, then the cops call the military, the Air Force, and they like bomb the shop just to take out that shoplifter. Totally disproportionate reaction, right? Same idea with what we're talking about, where in the case of Alzheimer's disease, the most direct cause of the symptom isn't necessarily the amyloid beta plaques and nerve fibrillary tangles. They're important, obviously, but it's the reactions in cells that those things cause, right, that cause the memory loss, the, all the symptoms of Alzheimer's disease. And so that's the same idea here, right? Okay, so what do you do about that? How do we interpret that, right? If those reactions, those cellular reactions aren't necessary, cellular reactions, so let's just focus on Alzheimer's disease, to amyloid beta neurofibrillary tangles, right? If those cellular reactions aren't necessary, they're just, they must happen. They just have to happen because of the way the cells are devised. If you can just prevent that military force from being called in, the store will still be standing despite the shoplifting, right? That's sort of the basic idea here. Slow things down a bit at a cellular level. And that's the fundamental concept behind this ISRIB molecule on which this group, Calico Labs, is focusing here, right? It interacts with that pathway, preventing stress from basically shutting down like almost all of the genetic activity in cells. And so this actually probably makes a little bit of intuitive sense. So, imagine you're trying to like read a book or watch TV or, maybe cook, yourself some dinner. You're in your kitchen, you're happily preparing your food, whatever it is. And then all of a sudden somebody just barges in and starts like loudly singing a song, not a particularly good song, a song that you don't even like, right? And they're doing it loudly. Okay. So you put on some headphones, not a big deal. You can accommodate this craziness. But then another person barges in singing a different song super loudly. Okay, you can sort of tolerate it, but they're starting to sort of like physically get in your way because they're dancing around you. You can't get to your knives, you can't get to your bowls in your oven, right? And then another person barges in doing the same thing. They're singing a different song and dancing around, and things are just getting super chaotic. And then they all start loudly shouting their songs, and they're now dancing together in a way that takes up way too much space, and it becomes basically impossible for you to cook anymore. And so you just stop trying to cook, right? Like just can't do it. And so maybe you call the cops or something like that, but your goal is ultimately to resume cooking at some point, maybe when they leave, they get out of your kitchen. But what if they never leave, right? Well, that's the sort of idea here at a cellular level. There's something going wrong caused by one or several of a variety of potential issues, right? And that thing, that stressor, that dysfunction causes the cell to stop doing what it would normally be doing. That's what the integrated stress response ultimately does. And so there are a couple solutions to this problem, right? First, you could try and forcibly remove those disruptive invaders, right? Second, you could try to just make them quieter, slow them down a bit, get them out of your way. And then third, you could just make it so that your ability to cook is totally unaffected by them being there. They can still sing and dance and do their thing, but you can still cook, right? Three basic strategies. And so that's sort of what the idea is here, right? Prevent those cellular disruptions from impeding normal cellular function, right? They can happen. Amyloid beta plaque can accumulate, but just because you're intervening in this integrated stress response pathway, it doesn't really matter, right? And so, after the kind of personal story that makes someone like me want to dive headfirst into lab work, Dr. Sadrowski ends up encountering a scientist with whom I briefly interacted when I started graduate school, Mauro Costamatioli. And so this work was several years before I ever met him. But he basically found that when he worked with mice whose integrated stress response pathway was altered such that it wouldn't respond in the same way, they seemed to generate incredible memory capabilities. Mice have, pretty impressive memories for such tiny little critters, but, they obviously have limitations. And I didn't realize that Mauro had done this kind of work. This was literally just like 3 or 4 years before I met him. It's just kind of wild. Anyways, so other folks in this whole orbit of scientists ended up testing this molecule, ISRIB, and they found that it not only wasn't toxic, great characteristic of a useful drug, right, if it's not toxic, but it also crossed the blood-brain barrier. So crossing the blood-brain barrier is a massive challenge when it comes to designing medications, right, drugs. The blood-brain barrier is basically a part of our physiology that prevents the vast majority of molecules in the universe from crossing into our brain from our circulatory system, right, from our blood. And so that would suggest that it would be capable, ISRIB, this drug candidate, would be capable of not only interfering with this whole integrated stress response pathway throughout the body, which is great, but also in the brain. And then the group demonstrates that this molecule appeared to improve the memory of healthy mice, right? So not just mice that were confronting the types of things that conditions like Alzheimer's disease, induce, right? But just, mice just confronting the kind of normal age-related decline that basically every animal in the known universe faces when it comes to, cognition and memory, right? It's pretty compelling. And so anyways, the story of this biological pathway sort of branches out a bit, but ultimately some of these scientists collaborated and found that this molecule, ISRIB, appeared to also recover the loss of memory capabilities that can occur after a traumatic brain injury or a TBI. And then this group found that this molecule appeared to enhance the memory-related performance of mice who reached, the age that would be the equivalent of when we humans start to experience, detectable age-related declines in memory, right? Super cool. Okay, now all that said, I have to be honest, as I'm reading these articles, as well as some of the, the quotes from the scientists participating in this whole story, I can't help but detect a bit of hype. Okay, I don't know. Maybe it's just an acquired cynicism, that pretty much everybody who goes through graduate school develops. It could very well be that it's just cynicism, but I just can't help but react with a bit of skepticism when I hear anyone, even when it comes to scientists whom I know are brilliant and excellent, claim that any one molecule is capable of targeting disease states that range from Alzheimer's disease and aging, right, to traumatic brain injury, right? There are some similarities across these various disease states, but not that many. That said, this whole cellular pathway, right, the whole reason that I spend any time talking about, this chaotic schematic, right, that cellular pathway it's one of those like utterly fundamental systems throughout the body, right? In basically every meaningful cell in our body, okay? And so, since we're talking about diseases that affect the types of cells in the body that are both some of the oldest in the body, by the time that we're adults, your neurons, and we're also talking about one of the pathways within those cells that respond to essentially any kind of dysfunction or insult or injury. Perhaps there's something to it. Perhaps it does make sense that it would be this sort of like broad strategy to treat a whole variety of maladies. However, even beyond my sort of reflexive and given, what I've seen, that's all this is, reflexive, right? Even beyond my reflexive skepticism towards these kinds of broad claims of efficacy, I can't help but consider what the broader ramifications of basically cutting the brakes on the cellular response to stress might be. And so this molecule, unless you're thinking that it, or a molecule like it, unless you're thinking that it would be injected directly into the brain, right? Which once again, this molecule prevents stress-induced reductions of protein expression, from occurring, right? It prevents that from happening. This molecule would theoretically be distributed throughout the entire body, not just the brain. And so, if you're taking it orally, let's say. So imagine a scenario where someone is, perhaps in their early 60s, older, sure, but still totally functional by today's standards. But this person is starting to show signs of problematic cognitive decline, maybe indicative of something like the earlier, onset of dementia. And so, as the evidence shows, if they're suffering the consequences of things that cause Alzheimer's disease, right, or the byproducts of traumatic brain injuries from when they were younger, if they're just now starting to show these signs of the effects of those conditions, various cells in their brain are starting to have that integrated stress response pathway kick into action, right? And so as a result, protein expression is inhibited, right, in a whole variety of neurons. And now, now that they're a bit older, because of that inhibition, it's starting to become a problem for them because they're getting insufficient cellular activity. And so we try out this molecule that prevents the stress response from inhibiting protein expression, and we successfully turn protein expression back on. Awesome, right? However, as we get older, the brain isn't the only part of the body that starts to act up, right? Cells throughout our body start to misbehave, accumulating errors in genetic expression, right? Most of the time, these errors are totally inconsequential, and you don't even know that they ever happened, right? We have systems within our cells that work kind of like this whole integrated stress response pathway, different systems. Those systems respond and either correct those errors or just prevent those errors from generating a problem, right? They just remove a problematic protein or they correct its folding. But, when the system that puts the brakes on the thing that's producing those errors are cut, right? And the errors are just being cranked out, as fast as they would be in my daughter, right, who's just growing a mile a minute, right? And these errors are building up as fast as they would when we were children, right? I can't help but imagine that there might be some potential consequences. So one obvious consequence, and if it's occurred to me, then I'm 100% certain that scientists as brilliant as these have thought about this, right? But one potential consequence would be that cells through our bodies that are misbehaving in a way that could ultimately develop into disease states, those errors might be amplified, right? Whereas naturally they would have been inhibited by this integrated stress response pathway. So sounds better than ivermectin. Exactly. Stanley says, my father and grandfather had dementia. Just got here, so we'll have to catch up. Question, is it my fate to suffer this? Your father and your grandfather had dementia. So it's not necessarily your fate. There is absolutely a genetic component to dementia, though. And so, it's just the kind of thing, I don't know how old you are, but it is the kind of thing that, you want to just keep an eye on. Again, it does not mean that it's inevitable, but it does run in families. Runs in my family as well, by the way. And so, hopefully by the time, generally speaking, unless they had a rather aggressive form of dementia and their onset was like in their maybe mid 30s or 40s, that's very rare. Maybe when you 62, 63, when you start to get to that age, it's just the kind of thing that you might want to just keep tabs on, because the earlier you intervene, the longer you'll be able to delay, potential decline. And then hopefully by the time you reach that age, we'll have maybe this medication will be available and it won't even ever be a problem for you. Maybe 65 now. Okay. Still working. Okay, great. Well, that's a good sign. I don't know when their dementia, when the onset for them was. I mean, it can begin rather late in life, depending, and different forms of dementia have different onsets and obviously slightly different symptoms and stuff. But if you're 65 and you haven't noticed any decline, I mean that's a good sign. But still, you just want to keep tabs on it. It's good that right, to keep an eye on. Cynthia says, "Hello, my first time on here. What are you talking about?" Well, welcome, Cynthia. Thank you for joining. So I'm talking about a new drug candidate called ISRIB, a new medication, right? And what it does, and the claims are that if it works the way that that the scientists that are studying it, if it works the way that they claim it works, which is interfering with this pathway, which is called the integrated stress response pathway. This is a system within essentially every cell in your body. And what the system does is that when that cell is exposed to a cellular stressor, so amino acid deprivation, in other words, malnutrition or insufficient nutrition, viral infection, things like that, right? That's what stress means to a cell. This pathway responds, and it basically stops the cell from cranking out all the protein that it normally would, right? So it's sort of like, shut the factory down, there's something wrong. And then it also at the same time activates a whole, a special constellation of genes that then work to either repair the cell, repair the cell and or just stop the damage from occurring in the first place, right? So it's sort of like, if there's something going wrong in a factory, you turn off the production line, and then, people step back, production stops, and specially trained people then go and try and diagnose a problem at the factory. That's essentially what this system does, the integrated stress response pathway. And their argument is that basically when it comes to Alzheimer's disease, traumatic brain injury, Parkinson's disease, as well as some of the dysfunction associated with Down syndrome, so pretty unrelated conditions, right? It isn't the things, the proximal cause isn't the amyloid beta plaques or neurofibrillary tangles when it comes to Alzheimer's disease. It's not them that are directly causing the symptoms that we associate with dementia. Rather, it's how the cells around the neurofibrillary tangles and amyloid beta plaques, how those cells around those things are responding. And what their argument is that response, the response that generates all the problems associated with dementia, is at least in part caused by this system, right? And what the system does, again, shuts down the factory, right? And what their argument is that if we can stop that from happening, then all of a sudden, perhaps it's not a big problem that somebody has amyloid beta plaques and neurofibrillary tangles. By the way, people do have amyloid beta plaques that never develop dementia. So it's an interesting, I think it's an interesting argument. Okay. So, yeah, I'm just wrapping up the topic now. But so there's a concern there, though, right? If we are to cut the brakes, if we are to prevent the factory from being able to shut down, then, there might be some negative ramifications there. And so, one, obvious consequence might be that a cell that's misbehaving and generating dysfunctional protein, that this system, this integrated stress response system, is inhibiting, preventing it from really, just spewing out problematic activity. If you prevent that from being inhibited, then that error, that misfunction, can be amplified. And so you can potentially have an increased likelihood of things like cancer, potentially. And so just to illustrate this, literally, and you'll see why, there's a book that my parents used to read to me when I was a baby, which naturally I got for my baby. And there's a particular part of the book that perhaps illustrates what I'm talking about better than I can describe. So it's a book called Streganona, or Streganona. And so there's, you can tell that I'm raising a baby, right? But so that's right where my brain went, for an example. I'm sure like 90% of people are like, never even heard of this book. But anyways, there's a similar concept to this part of the book. So the idea in this book is that there's this magical pot that can produce infinite amounts of pasta, right? Streganona happens to know exactly what needs to be done to produce exactly the needed amount of pasta to feed her whole town, right? She knows exactly what mechanisms to activate and when to deactivate them, right? But when this little youngin starts, tries to use her magical pasta pot, and he doesn't activate all the necessary mechanisms. He hadn't quite learned exactly how to interact with this system, this magical pasta pot. And so he misses one of the mechanisms that turns it off. And so he almost completely destroys the village with all of that pasta. I know this is sort of a torture comparison, but I can't help it. But same kind of idea here, right? If you cut the brakes that are normally always there from birth, it's pretty difficult to anticipate what might happen in all kinds of weird, unpredictable ways, right? All kinds of wacky proteins might be expressed at absurd levels that normally would never happen. And so once again, I'm 100% certain that they've absolutely considered this. I don't know what their intended solution might be, but at this level, I'm 100% certain that they've at least had to answer this question when giving a talk either at a different university or in front of investors, right? But all that said, it is super fascinating and it's super exciting because there really aren't any new compelling treatments for dementia or traumatic brain injury for that matter, really most brain-related conditions. Aducanumab is a new drug that came out, which is a whole different chaotic story. I recommend you look into it if you're interested in biomedical science. But this is definitely something that I'll be tracking, right? Because it's super exciting, particularly since it's a whole cellular pathway that I haven't seen targeted by any medications to date. And even just that alone is pretty exciting. And I should note that when I started graduate school, the project on which I thought I was going to work was focusing on a similar system, not the integrated stress response pathway, but a similar system called the ubiquitin proteasome system, which is basically every cell's system, well, one of the systems that they use to flag a protein, an errant protein, or an erratic protein, or a misfolded protein, misfunctioning protein, tag those proteins for destruction in the proteasome, right? And so the idea behind my project was that what if we could use that system, the ubiquitin proteasome system, to eliminate amyloid beta plaques and neurofibrillary tangles for Alzheimer's disease, right? Use that system and just sort of like, hey, ubiquitin proteasome system, target those things, right? And I didn't end up working on the project, but super complicated. And the reason that projects like this are both exciting as well as extremely difficult is that these systems are very complicated. It's not like just designing a drug that binds a specific receptor, one receptor that does essentially one thing, right? Which is what essentially any medication you can name does. Rather, you're trying to very precisely intervene in a very complicated biochemical cascade, very complicated set of interactions between parts of cells. And you're trying to have a very specific desired outcome. But when you have so many factors, so many moving parts to that machine, and you tweak just one part of the machine, you never know what's going to happen to the rest, right? And so anyways, that's what I have for you today. If you dig this kind of discussion, maybe you'll consider subscribing and liking and, wherever you're watching this, all that kind of thing. Otherwise, I will see you next week. And thank you so much for joining. And I hope you have enjoy the rest.